Okay, I ran out of time in that last video, and so let me go back to this idea about the definition of a ellipse. It is the set of all points in the plane, so it doesn't really matter where you put the point at. If you were to draw a line from any point down to both of the foci and then add up those distances, it would be the same number as if you did that from any point on that curve. And a lot of times, in order to draw an ellipse out, like in a classroom setting, what we usually do is to put two things on the board or something, something you could attach. Even on like a cork board or something is nice. You could put in some thumbtacks and then a piece of string. And you would take the string and put your, like say we have a loose piece of string here between these two. If I were to take my pencil and then pull it up until the string is completely straight here, and then I were to go all the way around holding that string completely tight, then we would have a perfect picture of an ellipse. Alright, now back to our parts for this video. We need to talk about the formulas for an ellipse. We have two different formulas here, and they might be hard to read, so I'm going to write them out a little bit better. This first one says x minus h quantity squared plus y minus k quantity squared. The x minus h quantity squared is over a squared, and the y minus k quantity squared is over b squared, and those are equal to 1. Now, we also have another version of it that looks very, very similar. X minus h squared plus y minus k squared. That should look very familiar from our circle formula. But this time, the x binomial is over b squared, and the y binomial is over a squared, and those are equal to 1. These formulas are absolutely identical, except the a squared and the b squared switch places in the ellipse formulas. Now, there's a reason for that. The reason is because a is always the largest number when we're talking about the ellipses. A is also the distance from the center to the major vertex. So, for instance, if here is my center in this ellipse, then A would be the distance from the center to this major vertex. That's why it's always a larger number, because remember, the major vertex is the longest side. Well, if the a squared value happens to be under the x, that tells you that it's elongated in the x direction. If the a squared is underneath the y, then that would tell you that it was longer in the y direction, up and down. It would be stretched out up and down. Now, we also have a b value here. B is the distance from the center to the minor vertex. So remember from my explanation in the previous video, this would be our minor vertex here. So B is the distance from the center to the minor vertex. And again, there we would have a B value the opposite direction also. Likewise, an A value the opposite direction. Now, we also have a C value in these. C is the distance from the center to the focus. And remember earlier I put my focus here. Then this would be our C distance from the center out to the focus. We have a major axis that runs through the center, the vertices, and the foci. And there is a relationship between A, B, and C. And that relationship is A squared minus B squared equals C squared. And we're going to figure out how to use all of these in the next video.